Welcome to our deep dive into the Retain API, a new experimental feature in Jetpack Compose designed to solve persistent state challenges. If you've ever struggled with state loss during configuration changes or navigation transitions, this API is set to change the game. We'll explore how Retain fits into the Compose ecosystem, its advantages over existing solutions, and why developers are excited about its potential. Let's start by understanding the context and motivation behind this innovation, and set the stage for a journey through its features, use cases, and best practices. Before we proceed, it's important to note that the Retain API and its related components, RetainObserver, RetainedEffect, and RetainScope, are currently experimental. Available in recent development builds, these APIs are still incubating and subject to change before their stable release. Names, behaviors, and artifact coordinates may differ in the final version. Developers should keep an eye on official Jetpack Compose documentation for updates. This means that while Retain offers exciting possibilities, you should use it with caution and be prepared for future changes. Jetpack Compose has revolutionized Android UI development with its declarative approach and robust state management tools. Traditionally, developers have relied on rememberSaveable, and ViewModel to preserve state across recompositions and configuration changes. Each method has its own trade-offs, especially when dealing with large objects or complex subscriptions. The Retain API aims to bridge these gaps, offering a Compose-native solution that keeps state alive during transient destruction scenarios, all within the composable world. To appreciate the Retain API, let's first understand the state persistence problem in Compose. While Remember survives recompositions, it loses state on configuration changes. rememberSaveable can handle configuration changes and process death, but only if restored via save state mechanisms and within size limits. ViewModel survives configuration changes but requires moving logic outside composables. These limitations often force developers to compromise, especially when working with large objects like bitmaps or media players. Retain sits between Remember and rememberSaveable in terms of how long it preserves values. It's designed to provide a Compose-native solution for surviving configuration changes without requiring serialization. However, Retain does not survive process death. Its behavior during navigation transitions depends on the host library implementation. This makes Retain ideal for scenarios where state needs to persist across configuration changes, but not necessarily across process death. Let's quickly compare the main state management options in Compose. Remember survives recompositions but not configuration changes. rememberSaveable survives configuration changes and process death, but only if the value fits within bundle size limits. ViewModel survives configuration changes and is suitable for shared state, but requires moving logic outside composables. Retain persists values across configuration changes without serialization, but does not survive process death. This comparison helps clarify where Retain fits in your toolkit. Using Retain feels almost identical to Remember. You simply call Retain with a key and a lambda to initialize the value. For example, in an ArticleScreen composable, you can use Retain to load an article by its ID. If the user rotates the device or the activity gets recreated, the article remains in memory. No need for refetching or serialization. This seamless experience makes Retain a powerful tool for managing local state in Compose. Compelling real-world use case for Retain is managing media playback. With Remember, rotating your device would recreate the ExoPlayer, causing interruptions. By using Retain, you avoid player recreation during configuration changes, ensuring smoother playback. Lifecycle events are handled with DisposableEffect, and player cleanup is managed with RetainedEffect. This approach reduces playback interruptions and offers a more robust user experience. When using Retain for objects like ExoPlayer, it's crucial to handle lifecycle events properly. DisposableEffect is used to manage pause and resume actions, ensuring the player responds to lifecycle changes. RetainedEffect is used for cleanup that should only happen on permanent removal, such as releasing the player. This distinction is important for avoiding resource leaks and ensuring smooth operation during configuration changes. Retain is managed internally by RetainScope, which defines a boundary for temporarily removed content. Developers don't directly control RetainScope. It's handled by the Compose runtime. The lifecycle of a retained value involves retention beginning, content exiting composition, values being handed to the scope, and restoration when composables return with matching keys. Unused retained values are retired and cleaned up. This mechanism ensures efficient state management without manual intervention. Lifecycle of a retained value follows several steps. First, retention begins when the scope is notified that content is about to be temporarily removed, such as during a configuration change. Next, content exits composition and values from remember are forgotten, but retained values are handed to the scope. When the composable returns with matching keys, the retained value is restored. Finally, retention ends and unused values are retired. This process ensures state continuity across configuration changes. Retain allows you to use multiple keys to invalidate retained values. For example, in a user profile cache composable, you can use both userid and refresh token as keys. When either changes, the retained value is refetched. This flexibility makes retain suitable for scenarios where state depends on multiple factors, ensuring that updates are handled efficiently and accurately. RetainObserver is an experimental API for objects that need lifecycle awareness. By implementing RetainObserver, you can respond to events such as retention, entering composition, exiting composition, and retirement. This is useful for managing caches or other resources that require cleanup or initialization at specific points in the lifecycle. Method names and behaviors may change before stable release, so stay updated with Compose documentation. Let's look at a practical example of RetainObserver. The Manage Cache class implements RetainObserver, providing methods for handling retention, composition entry and exit, and retirement. When a value is retained, you can log or perform actions. When it enters or exits composition, you can initialize or clean up resources. On retirement, you clear the cache. This pattern is useful for managing resources that need to respond to lifecycle changes. RetainedEffect is another experimental API in Compose, designed for running side effects tied to the retention lifecycle. Unlike DisposableEffect, which disposes resources when leaving composition, RetainedEffect only disposes when the value is truly retired. This distinction is important for managing resources that should persist across configuration changes but need cleanup when permanently discarded. In the Analytics Tracker composable, RetainedEffect is used to track screen views and dispose the tracker when retired. This ensures that analytics tracking persists across configuration changes but is properly cleaned up when the composable is permanently removed. This pattern is ideal for managing side effects that are tied to the retention lifecycle, providing a clean and efficient solution. Both Retain and ViewModel serve similar purposes but have different trade-offs. Use Retain when state is local to a specific composable. You need to persist non-serializable objects, or want to avoid ViewModel boilerplate for simple cases. Retain is also useful for navigation flows where screens need independent state. Use ViewModel when state needs to be shared across screens. You need save state handle for process death survival, or business logic should be separated from UI. One best practice is to avoid retaining objects that reference activity, view, fragment, or context, except for application context. Retaining such objects can lead to memory leaks. Always use application context when creating retained objects, such as media players. This ensures safety and prevents resource leaks, making your Compose apps more robust and reliable. For reusable state objects, create factory functions using Retain. For example, a rememberImageState function can initialize image state with an image URI and initial zoom. This approach promotes code reuse and ensures consistent state management across your composables. Factory functions make it easier to manage complex state objects and integrate Retain seamlessly into your Compose apps. Sometimes, you need both retention and process death survival. In such cases, combine Retain with rememberSaveable. For example, user input can survive process death with rememberSaveable, while validation cache survives configuration changes with Retain. This hybrid approach ensures that critical state is preserved across all scenarios, providing a robust solution for complex forms and workflows. Retain API is currently in development and experimental. As of now, development is ongoing in AOSP, and the API is subject to change. Exact artifact coordinates may differ in the final release. Once stable, the dependency is expected to be available through Compose runtime artifacts. Always check official Jetpack Compose release notes for the latest information on availability and setup instructions. Use Retain, you'll need to add the expected dependency to your project. While the exact coordinates may change, the anticipated setup is implementation, Andrex, Compose, runtime, run, Retain, $compose version. Always verify the latest artifact coordinates in the official documentation before integrating Retain into your Compose apps. This ensures compatibility and access to the latest features. The Retain API represents a promising addition to Compose's state management toolkit. It elegantly solves the configuration change problem without forcing serialization or pushing logic into view models. Whether you're managing media players, caches, or complex UI state, Retain offers a lightweight, Compose-native solution. Its scope is tied to the composable's position in the composition tree, making it ideal for local state management. Retain is designed for non-serializable state that should survive configuration changes. It works well for caches, media players, and local UI state. Combine it with rememberSaveable when you also need process death survival. Currently, Retain is experimental, so monitor official Compose releases for stable availability. These key points will help you decide when and how to use Retain in your projects. Retain is scoped to the composable's position in the composition tree, not Android lifecycles. This means that retained values are managed within the Compose runtime, providing a more granular and flexible approach to state management. Understanding this scope is essential for leveraging Retain effectively in your Compose apps. Retain is particularly useful for managing caches, media players, and local UI state. Its ability to persist non-serializable objects across configuration changes makes it ideal for scenarios where traditional state management solutions fall short. By integrating Retain, you can enhance the reliability and user experience of your Compose apps. While Retain is powerful for local state, ViewModel remains the best choice for shared state across screens and process death survival. Combining Retain with ViewModel allows you to optimize state management for different scenarios, ensuring both flexibility and robustness in your Compose apps. Since Retain is experimental, it's crucial to monitor official Android documentation and Compose release notes for updates. API names, behaviors, and artifact coordinates may change before stable release. Staying informed ensures that your apps remain compatible and take advantage of the latest improvements. As the Retain API evolves, community feedback plays a vital role in shaping its development. Developers are encouraged to share their experiences, report issues, and suggest improvements. This collaborative approach ensures that Retain meets the needs of real-world Compose applications. The Retain API has the potential to become a staple in Compose state management. As it matures and becomes stable, developers can expect more features, improved reliability, and broader adoption. Keeping an eye on its progress will help you stay ahead in Android UI development. Retain works alongside other Compose features like rememberSaveable, and ViewModel. Understanding how these tools interact and complement each other is key to mastering state management in Compose. Each has its strengths, and choosing the right one depends on your specific use case. Let's revisit the media player example. By using Retain, you ensure that the ExoPlayer instance survives configuration changes, reducing playback interruptions. Lifecycle handling and cleanup are managed efficiently, providing a seamless user experience. This approach is especially valuable for apps with rich media content. Managing caches with Retain and RetainObserver ensures that cache objects persist across configuration changes and are properly cleaned up when retired. This pattern is useful for apps that rely on temporary data storage, providing both efficiency and reliability. Using RetainedEffect for analytics tracking ensures that tracking persists across configuration changes and is cleaned up only when the composable is permanently removed. This approach is ideal for managing side effects that need to survive temporary exits but require cleanup on retirement. In complex forms, combining Retain and rememberSaveable allows you to preserve user input across process death and validation cache cross-configuration changes. This hybrid approach ensures that critical state is always available, enhancing the reliability of your forms and workflows. Retain is particularly useful in navigation flows where screens need independent state. By scoping state to individual composables, you avoid unwanted sharing and ensure that each screen maintains its own state. This approach simplifies navigation and enhances user experience. Always use application context when retaining objects. Avoid retaining references to activity, view, fragment, or context, as this can lead to memory leaks. Following this best practice ensures that your Compose apps remain efficient and leak-free. Creating factory functions for reusable state objects with Retain promotes code reuse and consistency. This practice makes it easier to manage complex state and integrate Retain into various parts of your Compose apps. Combining Retain with rememberSaveable provides a robust solution for scenarios where both configuration change survival and process death survival are needed. This hybrid approach ensures that your apps handle all state persistence scenarios gracefully. Integrating Retain into your Compose apps involves adding the appropriate dependency and following best practices for state management. Always check the latest documentation for setup instructions and ensure compatibility with your project. Since Retain is experimental, monitor its stability and updates closely. As the API matures, new features and improvements will be introduced. Staying informed ensures that your apps benefit from the latest advancements in Compose state management. The developer community is actively exploring and providing feedback on Retain. Engaging with forums, sharing experiences, and reporting issues helps shape the API and ensures it meets real-world needs. Collaboration is key to making Retain a success. As Retain moves towards stable release, developers can look forward to more features and improved reliability. Keeping up with its progress will help you stay ahead in Android UI development and leverage the best state management tools available. In summary, the Retain API offers a powerful, compose-native solution for state persistence across configuration changes. Its experimental status means developers should use it with caution and monitor updates. By understanding its features, use cases, and best practices, you can make informed decisions about integrating Retain into your Compose projects. Thank you for joining this exploration of the Retain API in Jetpack Compose. As Android UI development continues to evolve, tools like Retain empower developers to build more robust, user-friendly apps. Stay tuned for updates, experiment with Retain, and share your experiences with the community. The future of Compose state management is bright, and Retain is a key part of that journey.